So in this video, you're going to see about work and energy. Class 9, work and energy. Work and energy, to do any work, you require energy. But what the mean of this word work that we can see in the next Science 1 Chapter 2 Work and Energy. To do any work, you require energy. Always we have to do work, but it required energy. Work and energy, the chapter divided in 5 parts: work, energy, mechanical energy, law of conservation of energy, and free fall. So today we're going to see only one part, that is work. In simple word, generally any mental or physical activity is referred to as work. When we walk or run, the energy in our body is used to do the necessary work. We say that a girl who is studying is working or performing work, but that is mental work. In physics, we deal with the physical work. Work has a special meaning in physics. So overall, these are the example where we can say the work done. But the work done, it is a mental work, it's a physical work, is depend on. If you are running, it means you are running with the energy. So the energy in our body used to do the necessary works. But when you are studying, that also say it is a mental work, because that time also you require energy, but you are doing a some work, but it's not a physical work. You are not moving, you're seated one place, you are studying over there, so it is a mental work. In that time your mind is working. It doesn't mean that every time your mind is not working, but there is always, whenever we do the work, we require to energy. The word work. Work is said to be done when a force is applied on an object, causes displacement of the object. That is the definition of the work, and you have to remember this work definition because you have to write down always a textbook word in your paper. Now, work done by a force acting on an object is the product of the magnitude of the force and the displacement of the object in the direction of the force. Thus, work equals to force into displacement. That is a formula for a work: force into displacement. About the displacement, we already know that we did in the previous chapter. More example about the work. When a child pulls a toy cart, force is applied along the direction of the steering while the cart is pulled along the horizontal surface. In this case, in order to calculate the amount of work done, we have to convert the applied force into the force acting along the direction of displacement. Now we can see the expression of the force and displacement. Let F be applied force and F1 be its component in the direction of displacement. Let S be the displacement and the amount of work done is given by W, that is work, equals to F1 into displacement, that is S. The force F is applied in the direction of the string that is at an angle with the horizontal. Let Q actually it is a theta with the angle that is the string makes the horizontal. We can determine the component F1 of the force F which act in the horizontal direction by mean of trigonometry. Cos theta, we know the formula base upon hypotenuse. Cos theta then base it is F1, that is the direction of displacement upon applied force. So F1 is equals to F into cos theta. The work done by F1 is F into cos theta into displacement. So your final expression is the work is equals to force into displacement into the angle. Unit of work. Work equals to force into displacement. In SI system, the unit of force is Newton and the unit of displacement is meter. Thus, the unit of force is Newton meter. This is called joule. 1 joule equals to if a force of 1 Newton displaces an object through 1 meter in the direction of the force, the amount of work done on the object is for 1 joule. 1 joule equals to 1 Newton into 1 meter. 1 J equals to 1 N into 1 M. In CGS system, the unit of force is Dian, that is displacement in centimeter. Thus, the unit of work done in Dian centimeter, this is called an erg. 1 erg, if a force of an Dian displaces an object through 1 centimeter in the direction of force, the amount of work done is 1 erg. 1 erg equals to 1 Dian into 1 centimeter. Relationship between joule and erg. We know that 1 Newton equals to 10 raised to 5 Dian and 1 meter equals to 10 raised to 2 centimeter. Now work formula we know force into displacement. So work equals to 1 joule, force equals to 1 Newton and displacement equals to 1 meter. 1 joule equals to 10 raised to 5 Dian and 10 raised to 2 centimeter. So 10 raised to 5 multiply with the 10 raised to 2, what you get? You get a 10 raised to 7 Dan centimeter. So Dan centimeter is known as the erg. So 1 joule equals to 10 raised to 7 erg. Positive, negative and zero work. Pushing a stalled vehicles. Catching the ball which your friend has thrown towards you. Tying a stone to one end of the string and swinging it round and round by the other end of the string. Walking up and down a staircase, climbing a tree, stopping a moving car by applying brakes. You will notice that in some of the above examples, the direction of the force and displacement are same. In some other case, these directions are opposite to each other, while in some cases they are perpendicular to each other. In these cases, the work done by the force is as follows. Positive, negative and zero work done is positive if the force act on a body in the direction. Work done is positive if the force act on a body in the direction. Work done is zero if the work act on a body in the direction perpendicular to its motion. Work done is negative if the force act on a body in the direction to its motion. So here we can see about the positive zero work and negative work. Now we can see the example of work. Pushing something horizontal in example of positive work. Lifting something vertical upwards is an example of negative work. That's the example of positive work as well as negative work. Here you can see the activity in the table A, B. So first one, the cup over there, right? So here you can see the some changes in part A and part B. Put the cup on a table, keep one of the nut in the cup and let the thread carrying the other nut hang down along the side of the table. What happened? In B, the cup is sliding along a table. Stop it putting in a ruler in the path. And C, keep the cup at the center of the table. Leave the two nuts hanging on opposite side of the table. So in the first one, we can say it is a positive work. In second one, we can say it's a negative work. And in third one, we can say it's a zero work. That way, I think these all things are clear to all of you. What the mean of positive, negative and zero work. When any work we can do enthusiastic with our 100% effort, so it's a positive work because always be success. But any work it is we put it on you, but you don't want to do that. So you feel just you have to do the work without your interest. So it is a negative work. And you done a work and you return the same position. So it's a zero work. Sometime you did good. Everything is a good. But what you get nothing. So it's a zero work. I revise to you. Please subscribe and like my channel in a YouTube, that is www.youtube.com/c/Pravesh Mishra. Okay, bye bye. We can see in the next part again.